We discussed moment of inertia in radius of gyration in our previous lectures. Now we'll see some theorem on moment of inertia. The first theorem is parallel axis theorem. So what is this parallel axis theorem says? The theorem says the moment of inertia of a body about an axis is equal to the sum of the moment of inertia of the body about a parallel axis passing through the center of mass and the product of the mass of the body and the square of the perpendicular distance between the two parallel axes. This is known as a parallel axis theorem. So what is that means? It says that the moment of inertia of a body. So this is a suppose this is a body. This is a body. And we have to find out the moment of inertia of a body about an axis. So we have to find out this moment of inertia about an axis, this PQ, this P and Q. So we can find out this moment of inertia of the body about a parallel axis. So moment of inertia of this PQ axis of about a parallel axis passing through the center of mass. So suppose this is the center of mass, and suppose this the mass of this whole body is capital M, and this is the center of mass. So we have to draw a parallel axis of PQ on going through the center of mass. So this axis is going through the center of mass and is equals to the parallel axis AP. So we can say that PQ is parallel to AB. PQ is parallel to AB. And it says that passing through the center of mass and the product of the mass of the body, and the product of the mass of the body is M, and the square of the perpendicular distance between the parallel axis. So this is the perpendicular distance. Suppose we represent this distance as H between the two parallel axes. So here it says that the moment of inertia about an axis is equal to the sum of. So what will be the sum of the moment of inertia of the body about a parallel axis passing through the center? Suppose this axis AB is passing through the center. So around this axis, the moment of inertia about this axis is I of G. Suppose moment of inertia about this axis is I of G. And we have to find out the moment of inertia about this axis P and Q. So it says that this moment of inertia according to this axis I, or according to the axis PQ, is equal to the sum of the moment of inertia passing through the center of mass. The moment of inertia passing through the center of mass is this point, and the moment of inertia passing through the center of mass is I of G, plus and sum of the moment of inertia passing through this center of mass and mass of this body and the perpendicular distance between these two parallel axes square. So this is the main formula of parallel axis theorem. So I is the axis. We have to find out this moment of inertia according to PQ. And how we can find out this moment of inertia about this axis PQ? We can find out this moment of inertia about this axis PQ by drawing a parallel axis to this PQ, and this axis go through the center of mass. And when this axis go through this, like AB axis go through the center of mass, the moment of what will be the moment of inertia of this AB axis? It is I of J. So this is the sum of this I of J and the total mass and the distance between this parallel axis square. This is the sum of this. Total unit is equal to the moment of inertia. So this is the parallel axis theorem. Now we have to discuss another theorem. This is known as perpendicular axis theorem. So what is this perpendicular axis theorem says? This perpendicular axis theorem says that the moment of inertia of a plane lamina. So what is suppose we draw a plane lamina. This is a plane lamina. So we have the moment of inertia about a plane lamina about an axis. So we have to draw an axis. So we have to find out the moment of inertia about this axis, O Z. O Z. So see, it says that the moment of inertia of a plane lamina about an axis perpendicular to the plane. So this OZ is perpendicular to the plane, is equal to the sum of the moment of inertia about two mutual perpendicular axes in the plane of the lamina. So we have to draw two axes which is equal to the which is mutually perpendicular axis in the plane of the lamina. So this is the plane. So we have to draw two axes. One is, suppose we draw one axis which is this one, which is this one, and another one is this one. We have to draw these two axes. Suppose we write this as x axis and this is as y axis, ox and oy, and this ox and oy is actually parallel to the plane. So and there x and y are perpendicular to each other. X and y are perpendicular to each other and they are mutually perpendicular. So we have to find out the moment of inertia of this OZ axis. To find out this moment of inertia of this OZ axis, we have to find out, first of all, if I had know the moment of inertia according to this x axis like I of x, and according to this y axis I of y, then it says that the moment of inertia of z axis will be I of z will be equals to the sum of the moments of inertia about two mutual perpendicular axes in the plane of the lamina, such that three mutually perpendicular axes is a common point of intersection. This O is the common point of intersection, and the sum of these mutually perpendicular axes in the plane is Ix and Iy. We have to find out the sum of this Ix and Iy, and this Ix and Iy will be equals to the perpendicular axis of this lamina of the plane. So this is the perpendicular axis theorem. So we learned two theorem, and these two theorem are actually very important when we solve some conceptual math. Now we'll see an special case where we have to find out moment of inertia of a circular disc about a diameter and circular disc about a tangent perpendicular to its plane. So what that two means? So first of all, we have to find out the first case. It says that we have to find out the moment of inertia of a circular disc about an diameter. So what that mean? That means, suppose this is a disc. This is a circular disc, and we have to and the axis is in the diameter. Our axis is the diameter. So what is the diameter? As this is the center of this disc, so the diameter will be this AB. When we rotate this disc around this axis AB, and AB is the diameter, then what will be the moment of inertia? The moment of inertia of this will be I equals to m r square by 4. M r square by 4. We can prove this thing, but no need to prove the whole section. We just remember what is the moment of inertia and where the axis is lie. As this is the circular disc and the axis is lie on the diameter. Our axis is lie on the diameter, and in that case, the moment of inertia I will be m r square by 4, while m is the mass of this disc and r is the radius vector. R is the radius of this from point O to B, or OA equals to OB equals to R, the radius. R is the radius, and we know Another thing we know, the radius of gyration k equals to root over m by root over I by m, root over I by m. So if we have to find out the radius of gyration of this this first case, that will be equals to the m r square by 4 into 4 root. So we can cut out this m, and we will find out r by 2, r by 2. So this is the radius of gyration of this first case. So of this first case. Then coming to the second case. So what the second case is, moment of inertia of a circular disc about a tangent perpendicular to its plane. So our axis is the tangent perpendicular to its plane. So perpendicular to its plane, that means suppose this is the disc. Suppose this is the disc and this is the radius r. We have to draw a tangent perpendicular to this disc. As this is perpendicular to this disc, that will be like this. This is the axis, our AB axis. We have to find out the moment of inertia of this AB axis. That means our disc is rotating about this AB axis. At that case, our moment of inertia I will be equals to the 3 by 2 m r square. 3 by 2 m r square. For second case, our moment of inertia is 3 by 2 m r square. Please, actually, I don't prove the whole situation, but remember the moment of inertia and the radius of gyration of these two cases, and for the second case, what will be the moment radius of gyration? The radius of gyration I will be the root over of I by m, which is equals to the root over of 3 by 2 m r square divided by m, which is equals to the root over 3 by 2 r, root over 3 by 2 r. So this is the two case we have discussed in this video, and we have discussed two theorem of moment of inertia in that video. Please like this video and do subscribe to our channel. Thank you.